Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about creating custom exceptions. I'm going to open up my web browser to my website, javacjava.com, select Menu, Java OOP Tutorials. I'm going to scroll all the way down here to Creating Exceptions. This tutorial will show you how you can create your own custom exception classes. Now, throughout my previous tutorials, I've demonstrated many exception classes that are derived from Runtime Exception. Any class that is derived from Runtime Exception class, and error for that matter, is considered an unchecked exception. Any class that is derived from the exception class is considered to be a checked exception. Now, I will go into detail on the differences between the two exception types in a future tutorial. When creating your own exception classes, you are free to extend either exception or runtime exception. Now, it's not a good idea to extend error or throwable. The majority of the time, you should extend the exception class. This tutorial will build on my box class and demonstrate how to deal with that nagging issue of negative or zero value arguments. I'm basically going to show you the old way of doing it and then the new way of doing it. I'm going to come down here and highlight the source code. Control-C to copy, or right-click and select copy. I'm going to move my browser off screen here, come up back over here, and I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one very fast by right-clicking, selecting New Shortcut, CMD, Next, and Finish. It's just that easy. Let's go and open up our command prompt, type in javac, which is Java compiler command. You should see all this stuff scroll by. However, if you receive an error message, go ahead and watch my tutorial on installing the Java Development Kit. You want to make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space backslash. CD is short for change directories, and backslash tells it to go to the root. I'm going to make a directory called Java using the MD command. I already have that folder, but if you don't, it'll go ahead and create it for you. Change directories to the Java folder. We'll make a directory here called create exceptions. Let's change directories to the create exceptions folder. I'm on Notepad, create exceptions.java. Okay, make Control-V, paste that stuff in there, or you can right-click and select paste. We'll go ahead and come up here and save this. Okay, now there is a lot, there's a bunch of classes in this particular source code file here. So I've got create exceptions, which has my main method entry point in it. Then I've got this class called box old way. This has no error handling. We rely on method return values for success or failure. And I've got these three instance variables here, length, height, and width, all of int primitive type, and they're private, so they're encapsulated well. Now I got a no argument constructor here as well with a call to super, and yeah, I don't necessarily need that in there. It's implicit, but I'm just choosing to explicitly call it just to remind you guys that are learning language that it's actually there. So, and then I've got an overloaded version of the constructor here, box old way, that takes in 3 primitive int parameters. And it will set the instance parameters of length, height, and width equal to the, or it'll set the instance variables length, height, and width equal to these parameters length, height, and width there by using this and the dot operator. Now, what do we do about the constructor, right? I mean, how do we ensure that someone doesn't put in a zero value or a negative value? Okay, kind of a difficult topic to even consider how jerry-rigging that, but let's come down here to the setter methods here, right? Also known as accessor, or more accurately, mutator methods. And so on the set length here, right? So we can basically create a box object from either one of these two constructors, and then we can set the length, set the height, and set the width. So I've set each one of these methods up with a return value here, Boolean. Takes in the int parameter, right, length. So I'm checking to see if length is less than or equal to 0, and I'm returning false if it is. Otherwise, it'll continue executing down and say this.length equals length to set the local length instance variable there, and then it'll return true, so success, right? Same thing with height and set width. Now what we're really trying to get to here is our, the whole goal of all this is to ensure that our getVolume method doesn't ever return back 0 or a negative value, right? Because that's not good. We don't want that to ever happen. We want to ensure that our object state, our box old way state, in other words, its instance variables, always contain something greater than 0 when when using this object. Otherwise, it's kind of pointless. You don't have a box with a 0 volume. Otherwise, it's literally like nothing. And definitely don't have a box with a negative volume. I can't even argue if you turn your box upside down, the volume's negative, right? So, but anyway, let's just kind of pick on this one right here before we go into the new improved one that uses all error handling. But that's the box new improved error, all error handling. And then I'm going to show you what these two classes down here are. These are the new ones here where we're creating custom exception or handling classes there. So but let's come up here, and I've got right halfway through the main method, I've got this statement here that'll say error handling. So everything above here on these statements here is what we're going to pick on for the old way of doing it. So on this statement here, I'm creating a new reference variable old1 of box old way type and setting that equal to a new box old way object and invoking the box old way constructor, no argument constructor. Then based on our methods here, right? Set length, set height, set width, which return back true if it actually sets them, if the value is greater than or equal to 0. Now one thing about Java is when invoking a method, you can't force a developer to actually check the return value. They can invoke set length and do nothing with the return value, either true or false, that comes back with it. Java doesn't care. It doesn't require the developer to actually do that. So if someone is creating a new object out of our box old way class, they don't necessarily have to check any of this, whether we put it in the documentation at all. We can't force them to. We just can't force them to. So up here, I'm pretending to be the developer that's, creating this new box old way object using the documentation. They're like, okay, it returns back, true if it's successful, if the value is greater than that. Otherwise, it returns back false. So I'm just going to invoke the set length method passing it 4, the set height method passing it -6, and the set width method passing 7. You might be thinking to yourself, well, don't do that. But you know what? These values, even though I'm putting them in as integer literals right here, they may be collected from some sort of like input box or something like that. So the end user might actually be setting these rather than the developer that's using our class. So, but this just simulates some garbage coming in here and seeing how well our class can actually handle it. And so the developer who's using our class does his best and says, okay, so this returns back true, this returns back false. Our double and operator here short circuits and says, oh, we got a false. Everything inside of these parentheses is just going to return back false. I'm not even going to check. I'm not going to invoke this one here. So if not false, which is true, it'll go ahead and print out invalid argument measurement. And then it'll move on down the next line. So the volume of old1 is, and then old1.getVolume. All right. So let's check it out using the constructor here, right? So box old way type, assigning that to reference variable old2 of a new box old way object, and invoking the box old way constructor with 3 integer literals, -5, 5, and 8. All right, so coming down here, it's like, okay, good luck. We don't have any way of sending anything back, right? No return values. Constructors don't have a return value like a method does. Okay, so we got a huge problem right there. So I'm just going to go ahead and compile and run this, and we'll ignore everything below this error handling printout there. So let's go ahead and clear our screen. Java C. Okay, let's go ahead and invoke this. Okay, so let's come down here to there. So it printed out invalid argument measurement, right? But then, when we still invoke the getVolume method, it returned back 0. Then we invoke the getVolume method too on the second object, it returned back negative 200. So it's like, oh man, you know, from writing this box old way class, you know, it can definitely be abused, right? And there's no way from the developer who's writing the class to prevent anybody else who's creating an object out of it, you know, from really abusing it in the way we've got it set up there. So that's where error handling comes into, where we can actually force people to you know, listen to us and ensure that we don't end up with any garbage value, because we just won't let stuff like these two lines actually happen. Okay, I'll go ahead and clear the screen on this. So let's come down here. Excuse me. I'm gonna grab some water real quick here. Let's come down here to the box new improved class. The box new improved class has those same three instance variables, length, height, and width, and they're all private. We're all well encapsulated there too as well. Now I've left out the methods there just for simplicity on this, because I'm going to throw a lot at you here really quick, and I don't want to kind of overload you. I'm going to be going into greater detail on throw and throws in a near future tutorial here, but I've got basically the no argument constructor going right here, and I've got the overloaded constructor, just like I have up there, taking the three parameters, int length, int height, and int width. And you'll see this new thing here called throws invalid measurement exception. Now ignore that for the time being here, and what I'm checking for when the constructor is first invoked, I'm checking for if the length is less than or equal to 0, or the height is less than or equal to 0, or the width is less than or equal to 0. I'm calling the statement here called throw new invalid measurement exception. All right, now let's talk about these here. I'm going to spend a little bit of time talking about this here. So, class invalid measurement exception extends exception. All right. I've got a single constructor in here that takes no arguments, right? And the only thing it does in the constructor code block here is it invokes the super method, which is not the super method, the super constructor of the exception class, passing it a single string literal. Measurement argument cannot be 0 or negative. Okay, let's come over to the API documentation for the exception class. You know what, let's go to the Java 8 stuff here. Okay, so you can see the java.lang.exception is a direct subclass of Throwable, so it's really high up the hierarchy, right? And it doesn't have any methods, it only has constructors. So here's the constructors here, right? A no argument constructor, a constructor that takes a string message, which is what we've got right here. So this constructs a new exception with the specified detailed message. And you'll see this is actually much more simple than you might think at first there. So that's the one that's the super constructor that it's invoking when we call the super constructor here, and we invoke it and pass it this right here. Okay, so just keep that in the back of your mind. You'll see how this will work here in just a second there. Okay, so if these are less than or equal to 0, we're going to throw a new invalid measurement exception. All right. So one thing about a checked exception is that if within the constructor code block, if we throw a new exception class that is a subclass of exception, we have to put in this throws keyword right here, plus the name of the exception that's being thrown within the code block. Now that will flag the compiler that anything that actually, any subclass or object or whatever that actually invokes the box new and improved, it has to basically, well, for the purposes of this tutorial, I'm going to say it has to do a try catch with the invalid measurement being the catch. There's a little more to that but I'm not going to confuse you on that portion of it yet there. Okay? So there's one other thing here, and that's the get volume, right? Because we have a no argument constructor up there, it is possible to create a an object with all zeros in it, of course, right? And I put this in here for a specific reason. I'll show you why up top. It actually helps people who are going to be using your classes not come up with like null pointer exceptions and circumvent certain stuff like that, right? The get volume method, right? First thing I'm doing is I'm checking to see if length, height, or width, if any of those are less than or equal to 0. And of course it's checking these instance variables up here, right? And if they are, I'm doing a throw new initialization incomplete exception, right? Now, here I've created another custom exception class called initialization incomplete exception. I just made these up off the top of my head, but one of the standards is you always want to include the word exception after your exception classes. You know, they'll extend exception or whatnot there, right? So in the constructor of this one, I'm just calling the super constructor, right, which is exception sub constructor, and I'm passing it this string literal right here. Initialization of object state was not completed. All right, so all this is going to start to come together here in just a moment there. So get volume. Because we throw a new exception right here, we need to have this keyword throws up there plus the name of the exception that we're throwing here. All right. If this if statement, if either of these are less than or equal to 0, length, height, or width, it'll go ahead and throw this. And what happens is that this particular statement never gets executed. Any statements after a throw don't get executed. Like, for example, these three up here in the constructor, the length, height, and the width, the instance variables, never get set to the parameter length, height, and width as well. All right, so let's go ahead and come back up here. And I'm going to show you something interesting here. Now, the first statement I'm doing box new improved new 1 is equal to null. And the reason why I'm doing that is because new 1, we have access, it needs to be within the scope of the main method. In other words, inside the main method's code block here. If I were to do something like, let's say, for example, initialize it in the try statement down here, right? What we'd end up with here is, if you haven't watched my tutorials on like scope or even some of my previous exception tutorials where I talk about scope, this method new 1, or this reference variable new 1 would be only local to inside of the scope. We wouldn't be able to refer to it here. We wouldn't be able to refer to it here. So by initializing it or declaring it out here, new 1, and setting it equal to null, everything inside of the main method body here has access to this new 1. All right, so that should be fairly simple on that. So the first thing I'm doing inside of the, oh, let's just do this here. I'm going to do something real quick here. I'm just going to comment out this code here, and I'm just going to paste in this particular thing here, right? So one of the things that I talked about extensively here in the old way here is that we can't force anyone to do anything. We can't force the developer to check return values. We just can't force them to do this here, okay? But because this box new improved is throwing a checked exception, here's what happens if we try to do this outside of a try catch statement here, right? If we try to recompile this here, what it's going to do is we can't even compile it because it's going to say unreported exception, invalid measurement exception must be caught or declared to be thrown. So you have to catch that exception. Don't worry about the declared to be thrown yet. I'll go over that in a future tutorial. But so anyway, that's where we run into a problem is if we're running this risky code right here, this box new improved, outside of a try catch, the checked exceptions means the compiler will check to make sure that we are actually catching the exception that can be thrown. All right, so that is kind of a little just like a little top level description of what a checked exception is. So by enclosing this in a try catch statement there, it'll go ahead and try this new box, invoke this new box method here, not method, constructor, right? So we're setting our new 1 reference variable of box new improved type equal to null here. And then we're trying to basically initialize it to a new box improved object and invoke the new box improved in constructor with -5, 5, and 8. Now, what's going to happen when we come down here and we do that, new improved, it's going to say, okay, if length is less than 0, oh, guess what? Length is -5. We're going to come down here and we're going to throw the new invalid measurement exception, right? So the first thing we're going to do is catch the invalid measurement exception and assign the object to this E reference variable. And then I'm just going to display that, I'm going to use the E and I'm going to invoke the getMessage method, which is inherited from the Throwable class. So hopefully you've been watching all my other stuff there, otherwise I've probably just lost you. But that'll go ahead and just throw the message that for the invalid measurement exception there, right? Then I'm going to set new1 equal to a new box new improved method, right? Or constructor, or no argument constructor. So this will actually create a new object, so we won't end up with anything that's null, right? And because down here, my box new improved constructor, it doesn't throw anything or anything like that, we'll just basically have like a box new improved object that has the state of all zeros. All right, so let's check out what the next thing is there, right? So if we create an invalid, or if we try to create an invalid object, we're just going to end up with basically an empty object, right? Or one with like the default state in it there. Now that's okay, and that's good, right? But now when we invoke the getVolume, we don't ever want to return back that the volume is 0. So what we have to do is we have to, if we're going to invoke the getVolume method, we have to enclose it in a try and a catch statement for the same reason as up there, because the getVolume method in the new improved class throws the initialization incomplete exception, okay? So if we tried to do that, this particular line, right, I'll just put this up here, right? If we try to put this outside of a try catch, right, and compile this, we're going to get an error message on that. Unreported exception, initialization incomplete exception must be caught or declared to be thrown. And that's trying to invoke the getVolume method there. All right, so that's the way we can actually force people who are using our class, making an object out of our class, to actually force them to try and catch sort of stuff right here, right? And we can force them to catch the right stuff. If they were to put in, like, for example, runtime exception, well, runtime exception is not part of the hierarchy here. That's going to throw up a message. So they have to do something that's part of the hierarchy here for initialization incomplete exception. So if we catch that exception, which is going to happen down here, because basically we're dealing with a box new improved object, and its state is going to be length 0, height 0, width equals 0. And when we invoke this, it's going to throw a new initialization incomplete exception. It won't even return this back, right? And we will then trap for that exception because we have no choice to, otherwise we can't get our code to compile. And I'll just display that message to the console there. All right, so let's go ahead and save this here. Let's clear our screen, Java C to compile this again. Oops, just compiled the wrong thing. Okay, Java to run it. And so underneath the error handling section, we get measurement argument cannot be 0 or negative. And then we get initialization of object state was not completed. And then the end of the program. So nothing crashed the program out like that. We just would never return back anything like the volume of old 1 is 0 or the volume of old 2 is 0, right? So this forces the developer that's implementing our box new improved class to actually do exception handling. So if, for example, if they actually pass it a valid arguments, everything here is just going to work just fine. So let's just save that. Let's clear our screen. Java. Right. So underneath the error handling section, the volume of new one is 200. All right. Let's pass it in a 0 right in for there here. Right. Save. Measurement argument cannot be 0 or negative. Initialization of object state was not completed, right? So that is the beauty of it. Now we've had that nagging issue for so long that let's go with like 12. Let's save this and run it again. Okay, the volume of new one is now 300. All right, so by using the exception handling and custom exception classes, right, we are able to now basically ensure that anyone who creates an object out of our class here cannot invoke the getVolume method and have it actually return back some sort of 0 value or a negative value, some undesired result. They have to ensure that everything is done properly, or else they won't even get that back. They'll just get the exceptions that they're forced to handle at that point in time. All right, so I'm going to go ahead and get rid of that, and just leave you guys with some final thoughts here. So when creating your own exception classes, the majority of the time you should extend the exception class. Now, I introduced a lot of new concepts into this tutorial, like throw and throws, and I'll be going into more detail on the purpose of those two keywords and how they function in future tutorials. That concludes this tutorial. Thanks for watching.